Bolts don't stop uplift, load paths do. A common assumption is that bolting a container to its foundation makes it hurricane-proof. This is a dangerous oversimplification. In a high wind event, the container is not just being pushed sideways, it is being actively lifted from its base by a powerful aerodynamic force. A strong bolt in a weak system is a point of failure, not a point of security. To understand this failure, we must analyze the aerodynamic forces at play. A shipping container, with its flat top and sides, behaves like a crude airplane wing in high wind. As wind flows over the long, flat roof, it must travel a longer distance than the air flowing underneath. This creates a pressure differential, lower pressure on top, higher pressure on the bottom. The result is aerodynamic lift, or uplift. This is not a minor force. For a 40-foot container, a 120-mile-per-hour wind can generate tens of thousands of pounds of upward force, actively trying to peel the structure from the ground. This uplift works in concert with the more obvious shear force, the horizontal pressure pushing the container sideways. Uplift reduces the clamping force of the container on its foundation, making the shear force far more effective at causing a failure. The fatal error is focusing on the bolt and not the entire system it is connected to. A bolt is only as strong as the weakest link in its load path. There are three common failure modes. 1. Concrete pullout. The bolt itself holds, but the uplift force rips a cone of concrete directly out of the foundation pier. This occurs when the anchor bolt does not have sufficient embedment depth or is too close to an edge. The concrete, not the steel, becomes the point of failure. 2. Connection plate failure. The bolt and the concrete hold, but the steel plate used to connect the container to the anchor bolt fails. Either the weld connecting the plate to the container's corner casting tears, or the plate itself, if undersized, bends and rips under the immense tension. 3. Progressive loosening. The cyclical nature of wind gusts creates a vibration and rocking motion. An anchor that is not properly tensioned, like a simple expansion bolt, can slowly work itself loose over the course of a storm, leading to a sudden, catastrophic failure of the entire connection. The professional solution is not a stronger bolt. It is an engineered and unbroken load path. This path begins at the container's primary steel frame, transfers through a robust, full-penetration weld to a thick steel embed plate, travels through a properly sized, cast-in-place J-bolt with deep embedment, and terminates in a concrete foundation massive enough to act as a ballast against the total calculated uplift force. Every component in this chain is designed to be stronger than the forces acting upon it. This is why engineers specify cast-in-place anchors, which create a monolithic bond with the concrete, over post-installed mechanical anchors. It is also why industrial hardware like twist lock connectors, which are designed for the immense dynamic forces of ocean transport, are a superior solution. The system is designed to transfer the wind's lifting force into the dead weight of the Earth. The failure is not mechanical, it is systemic. A bolt is a fastener, not an anchor system. Uplift is an aerodynamic problem that demands a structural engineering solution. The integrity of the load path is what determines whether the wind is fighting a single piece of steel or the entire mass of the foundation.